our next presentation, I'd like to introduce Devin Dharm and Patrick Johnson. Devin is the Director of Software Engineering at Bolt Threads. He has over 2 decades of experience in leading complex information management portfolios and digital transformation initiatives, working across the healthcare and life sciences domain. Before joining Bolt Threads, Devin was working as a leader within Deloitte, advising large public sector accounts on analytics and information management. Patrick Johnson is a systems analyst at Bolt Threads. He joined Bolt in early 2018, trading the world of e-commerce for biotechs and textiles. Patrick has been the boots on the ground for the Benchling implementation, helping to mesh together scientific processes and system capabilities.
Thank you, Sajid. So today we'll be talking about who we are as Bolt and what we do. And then I'll talk about how and why we introduced Benchling, what was the drivers. Then we'll talk about how some of the use cases in terms of how we leverage Benchling for our work. Ultimately, then we'll discuss from an issue to impact, what impact Benchling has had on our company. And last but not least, we'll just talk about some interesting materials and some new work that we'll be doing in future. So at Bolt Threads, we essentially take inspiration from nature and leverage bioengineering to create some revolutionary materials with a long-term focus on sustainability, essentially creating better materials for a better world. Just imagine if all of these beautiful apparel that we wear were to be biodegradable. Today, these things go into trash and into landfill, probably stay there for hundreds and thousands of years. Our goal, our mission is to try and create materials which are essentially more sustainable. And how we do it is we do it by leveraging the basics of biology. So we started with spider silk, the spider webs that you see. We were able to reverse engineer that material, and we have been able to create or reproduce a protein very similar to that. And you can just imagine the numerous applications that a material like that, spider silk, can have. Not only did we create spider silk, but we have now also diversified into creating an alternate for leather. We have been able to successfully leverage the root structures of mushroom to create a material that basically can substitute leather. So tomorrow we'll be able to, or soon we'll be able to produce leather without killing animals. So that's kind of that's what Bolt does. So if you think about Bolt, today Bolt is more of a materials platform company. So we don't just do research and create these materials, but we also have the in-house capability to translate these materials into or conceptualize product ideas in terms of how we can leverage these materials, do the complete product design and development, and all the way up to taking these materials, these products to the consumer in a direct-to-consumer fashion. Many of you may have heard about the recent launch we did, which was last month, where we found a very unique application of the silk that we created. We leveraged it in a skincare beauty brand. We launched 18B. For those who are not familiar, can check out that brand, 18b.com. So essentially, the silk is the main ingredient within those beauty products. What it does is that it essentially it's probably the first. No, it is actually the first beauty product which leverages a whole silk molecule within it. It creates a lightweight, breathable barrier on the skin, which allows the skin to breathe while still being able to retain the moisture, which is what is the value that this product has. And feel free to check it out. So, Bolt, as I said, is a materials company, wherein we want to be able to bring out these materials and then create some innovative products out of those. In terms of overview of technology, I think a lot of you guys are familiar with this technology. Obviously, in terms of the different materials that we are creating, we are working on, the technologies are different. But just to give you a flavor of what we are doing. From a perspective of fibers, what we do is we take the natural sequences, study the natural sequences, and then do protein engineering to essentially create these proteins in labs. We maintain our own databases of plasminogen strains in order to specifically tailor the material that we want. Our goal is to be able to essentially program the polymers that we're creating. Once we have the protein powder or material, we extrude that through an extrusion process to create the fiber, which is then wound into or turns into a bolt of threads, of silk thread. That's how the name bolt threads came into being, which is used to create fiber products. Last year, we created a few product drops in terms of creating a silk dye as a sample of what is possible. We created sold caps, which sold like hotcakes. We are still not at a point where we can, mass produce these things, but it's very cool. If you want to follow us, feel free to check us out. As you can imagine, our company deals with a lot of complex materials. It's non-standard. It's not a standard life sciences kind of a, life cycle of how we do our research. So we needed a system that should be extremely flexible because we really don't know what we are going to work on next. Our engineers our scientists are really going wild in terms of all of the materials that can be produced with that perspective. What we did was we did a deep dive into what the journey map. We applied the process that you may be familiar called as design thinking, essentially to understand the various personas that exist on the current users of the system, and then created journey maps to understand what are the challenges that these folks face. And then after understanding the challenges, we realized that a lot of it is around data and being able to, collect data in a central place and being able to leverage data for a more insightful decision making. So that was kind of the backbone. And another major theme was that the fact that we don't know exactly how the process is going to evolve. So we need a super flexible LIMS system, which will allow us to evolve literally every day, every week. And that's where after doing these journey maps, we translated this into story maps or a vision document for our lab information management system that we needed, and then did a bake-off with multiple vendors. The process we used was a very successful process where we scripted a demo and gave Benchling that, hey, here's a script. This is what we would like, our users would like to see. And they were kind enough to literally configure the system to show how all of that can be achieved, which was extremely helpful because then all of my users could relate to what Benchling will be able to do for them. And then that's what gave this kind of results. So we evaluated Benchling on several different fronts, from a functional fit, technical fit, functional fit meaning, obviously whether it meets our use cases. Technical fit included things like what is their technology stack, in things like whether there is adequate support from the software community and etc. Usability, I think everybody understands. Learnability, we wanted to make sure that new users as they onboard, they should be able to learn this system quick enough. Flexibility was of paramount importance to us because we are going to be going wild with materials. We don't know what processes we might need. Overall appeal, ultimately, for a successful software system, people have to like it. So we included that as an explicit criteria, that what's the appeal of the system, and then the company fit in terms of how robust is their funding, how robust, the other things that we want to be sure that they'll be around for some time to help us when we need. We designed this in a 4-bucket rating where does it meet the needs? It meets partially, which means that it can be extended, or it meets as is, or it exceeds our expectation. And you can see that Benchling blew it out of the park. So kudos to Benchling. Thank you so much. And I fully stand behind this even after 1 year. After implementing this, I still feel this was a great decision that we made. So this is where Bolt met Benchling.
Yeah, the spider and the jellyfish got together. Yeah, so as Devin kind of mentioned, flexibility is one of the most important things that we were looking at in a LIMS system. And I'd like to just walk through 2 use cases to kind of highlight that. So Devin mentioned that we met with each team and we thought deeply with them about what their current journey maps were. We created those user personas and we thought hard and long about their problems. And we had an idea of how Benchling was going to solve those. Thinking in terms of the modules that you might be familiar with, for the biology team, we knew that they were going to be using the microbiology suite as well as the ELN and kind of a flexible way to track their data. For fermentation, RNS, which is what we call DSP, materials, and our fibers team, we knew that we were going to be leveraging the ELN and also the workflows to kind of structure their data, which was being defined. And all of those teams are going to be sending, using the request module, requests to analytical chemistry for their assays to receive those results back. But as they say about the best laid plans, there were things that we weren't able to predict. Oh yeah, there was another team lurking there within biology that was kind of just being discovered both at the company and by us during our implementation. This was in around August, I believe. We first met with biochemistry as a distinct group, different than the molecular biology group. So yeah, already here we were putting that flexibility to the test. So we met with them and we were like, hey guys, like what do you do that's different maybe from microbiology? We were still trying to understand this ourselves. So they were using column chromatography to purify small quantities of very, very high caliber silk protein for us. They showed me the work that they were doing. They were really proud. They had just built this 10-page worksheet that they were bringing into the labs, that they were writing down everything in by hand. They would sometimes take pictures of their columns and bust out the glue stick, put it in there. It was really, really difficult when we were talking to them to even like understand. We were like, oh, cool. How do you record your results from ELISA here? They'd be like, oh, a chemi has that. I don't have that on my desk right now. So the handoffs between people were very difficult for them. There were a lot of challenges. What was also interesting when we first met with them, they were a little bit skeptical as to what value the system can bring them. They weren't kind of aching and ready to jump in. They weren't like, yeah, give us workflows. We were like, we're pretty sure workflow might help here. So we sat with them and we kind of iterated through as they were realizing that there was more structure to their process than they originally thought. There were certain parts that needed to stay very, very like agile, but there were parts that they were writing down the same data all the time. So this is what we came up with together. I've blurred out some things here. Thank you, legal. So yeah. When we first met them, they had just done 4 runs of column chromatography. It had taken them about a month, and they were using those hard paper copies and those glue sticks. In February, they were asked to take on a lot more, bump it up an order of magnitude to make far more than they had ever produced. It took us a while to kind of get here, as you can imagine. Iterating, this is probably like version 27 of this workflow, working with Ryan, who's a saint. But in February, they were asked to do a lot more, and they would start a column one day, and then which one column would relate to one experiment here, one workflow. The next day, they would start a new column. They had 14 of these going concurrently in February, and I'm going to try and directly quote Ryan here. I wouldn't have been able to track my data like this if I didn't have this sort of tool, right? So we're seeing huge benefits there. Also, different scientists were jumping in at different stages of these workflows to take over work, and you can kind of see, like, right now there's ELISA right here. Like the results that you were sending off to ACHEM were already being incorporated right back in. And you didn't have to take time to jump into an Excel template and that you've maybe built yourself and kind of run like a concentration and volume calculation. Again, it's just kind of all taken care of for you. He pointed to a part of this workflow that was blurred out right now. And he was like, yeah, having that right there, that makes a huge difference in my life. This intermediary entity that kind of represents and wraps up all of these previous complex steps. There's maybe like 8 more steps that literally couldn't fit on my screen when I took this screenshot. This was kind of a huge win for us. We didn't know if Benchling was going to map well to biochemistry, but we had chosen a flexible system, and it mapped really well. Yeah, Devin kind of alluded to this earlier when we were choosing our LIMS system. This was back in, I think, April and May, our first demonstrations were. we were almost entirely focused on these spider silk molecules, right? Our Bolt brand here, our 18B molecule, which is also the name of our skincare brand, 18B. Check out the website. Yeah, so we all of our customers, all of those journey maps, right, were for these teams. We had heard that there were rumblings, right, that this other material, that Bolt was going to kind of move from a spider silk company to a biomaterials platform company. So that was coming, and we were kind of confident, I would say, that when we introduced Milo, we were going to be able to find a way for Benchling to work with it, which was good because if we come back here to our high-level teams, Milo became more and more grew in importance at the company. They launched a bag on Kickstarter, and we were still kind of knocking these guys off, going down our list of customers. When all of these guys came and asked us if they could start using the system, we were like, "Whew, okay, yeah, this is great." That's exactly the sort of problem that you want to have when people within your company are walking up to you and saying, "How can we start using Benchling?" There's obviously seeing the value. There's talking about overall appeal. They were able to see that there was more that they could do if they were able to track their data well, because it's a challenge to come up with systems like that on your own. So I'm just going to take what was also really cool here, of course, I don't know how much you know about growing mushrooms and making leather products about them, but I'll go over really high level what this takes. At the Grow Lab, basically, you're taking this big bin, right, and you're packing it full of all the things that mushrooms love to eat. You're sprinkling in some inoculum. You're putting it in conditions that mushrooms love to grow in, and then you're kind of pulling out this big foamy pillow of we call it wet foam. It's an entity now in Benchling, which is fun. Then you cure that, quote-unquote cure, quote-unquote tan. These are different processes than leather would go through, but you kind of give it a texture, you give it a color, and then at the end of the day, we had a quality team, basically analogous to analytical chemistry, that performs those assays, those physical material assays on that product. So we had an idea. We actually saw some really, really great parallels between these. Like the grow team, the substrate that they were packing was not too dissimilar from the media that fermentation was using to grow their fermentation batches. The quality team, they were going to be sent requests very similar to the analytical chemistry team. So we could leverage a lot of those same, not the same templates, but the same thought process to build that out. So let's just take a step back at the high level of where we are today at Bolt. This is the part where I like to talk about the grassroots movement. I talked about those different teams within Bolt kind of coming up to me and asking, how can we get on the system? Literally today, it happened again. Micah from fermentation and Cody from biochemistry came up and were like, "Patrick, we've got this great new idea. We want to be able to track, the processes for the strain, make sure that we are able to track all of these parameters. We've got this great idea. We're just going to go back and workshop it, and then we'll come back to you in a little bit." I'm like, "Oh, great, guys, that's awesome." From a data governance perspective, maybe it's a little scary, but I'm glad that our users are excited about this. For example, Maxime, all of these teams have settled into the system differently. Maxime here, he's looking, it's very, very small, but there's a fiber that he's looking at that's kind of held between two things. He took to the system very, very quickly. He has built out his own workflows, his own entities, his own data tables. He's kind of taken ownership of his corner of the world. Whereas, for example, the Grow team, I've been working in conjunction with Lorena and Jose to kind of build out those new workflows for them. So yeah, there've been a bunch of benefits. I'm going to turn it over to Devin to talk about these high level.
Yeah, so if you think about what Benchling has brought to Bolt, from a place where we had so many scientists working on a whole bunch of disconnected systems, we had over 600 different data silos within a fairly small company. It was almost impossible to get data out. All of the data was going in somewhere in one of those 600 places, either in Google Sheets or databases or micro databases or whatever. The handoffs were difficult. Sample submissions was not automated. Things of that nature. From that place where now all of the scientific community is consistently using one single software for all of their need, which has been the biggest differentiator for us. We have been able to eliminate those data silos. We have engineered the system such that data lineage is built into the design. We can track all the way from strain to the product that is in the market. We can track that lineage in a clean manner. So it has been a highly rewarding experience for us, and huge thanks to the Benchling team. The one thing that doesn't get talked about enough about these vendors, I have been working in the industry for 22 years, but ease of working with vendors, I think, is one of the biggest factors that makes systems successful, system implementations successful, and I think that has been a great thing about working with these folks. I think that's pretty much the standardization. I think, yeah, that is another value that we got out of this. We have been able to standardize the processes to an extent that now when we have to move towards manufacturing, we can actually take the template from Benchling and give that template as essentially a template for how the manufacturing process has to evolve.
So what's next? Kind of, we've been rolling out Benchling to these different teams. We have a couple more part of the Milo TM process that we're still working with, but there are other things that we're excited that Benchling kind of lets us do. The first is these are live dashboards. By plugging into Benchling's data warehouse, we've been able to leverage. We in-house use Tableau, but you can use any data visualization tool. It's funny. This morning, Jin was giving me flack. It's impossible to draw any statistical or any real conclusions from this. This is all of our batches, right? For elapsed runtime and the dry cell weight. You would really just pick a couple of these where the parameters are very similar. But I just kind of wanted to show you all of these are really right here, and you can pick and choose by operator, by which batch number there was a run on. We have a couple of these dashboards. For our scientists, we want more. They want more. Using a tool where you're kind of meticulously recording your data, a lot of times it can feel like work, like extra work that takes time, takes you away from the lab, right? I think Benchling does a great job of letting you record the stuff once in real time, but once you have good, clean data, these are some of the benefits. Improved visual and statistical analysis. So we want to continue rolling that out to our scientists. The next step are, another big next step for us is instrument integrations. This is Adam, and Adam is standing right here next to Agilent HPLCs. Adam is an analyst on the analytical chemistry team, right? People send him samples, he performs assays upon them. Right now, Adam's job he looks really happy here, but his job is kind of tough. The software that he uses is from pre.com era. It's tricky. You have to copy and paste from these PDF reports into Excel. He's got these wizardry level Excel templates that clean stuff up on his end, and then he's importing it into Benchling. That's not great. It's not where we want to be. It works, and it works really well. Thanks to a really great member of the team like Adam. But we want to be able to, and we are able to spruce up that process because Benchling has a great API that we can interact with. Instrument integrations are a huge next step for us. And after that, I just want to say thank you. As Devin said, we really can't predict what the next big thing is going to be coming out of Bolt, but we're excited because Benchling has been a great fit for us today, and we're going through this unpredictable process, right? We're excited because we think that's going to be a good pick for us tomorrow too. Any questions?
So just curious, the API for instrument integrations, and you spoke about cutting and pasting chromatograms into your backend workflows. Mm-hmm. So just how evolved is that right now? In terms of, is it fully electronically capturing the chromatogram and putting it into a data sheet, or how do you see that developing?
Oh, that's a really good question. A lot of our customers have been asking for exactly that because they want to see those chromatograms in a tool like Tableau. Right now, because a lot of our processes have been focused on 18B, I'm going to try and answer this question the best I can. Right? I'm not a scientist, so if I flub something, please forgive me. A lot of our focus has been on 18B. We had a scientist write a custom Python script that kind of looks at, we know there are certain areas where these peaks are going to show up, so we're kind of performing that, running the data through that script. We can automate that sort of stuff and then just like send it back in through Benchling's API. Right now, those files come out as these like gnarly XML things. They're not great. We've kind of prioritized rolling the platform out to our customers here. So we kind of said like, oh, once everyone's on the system and happy and like have a manual way that works, then we're going to step into instrument integrations. So I'm kind of excited to learn more and get to that piece. Things that we've used the API for in the past, we used it to run autofill parts kind of as like a nightly job on our plasmids and oligos and landing pads because it's really easy to forget to press that button. So Benchling's API is already there for us. It's kind of more on us to dig into our own internal systems. Do you have anything else there?
No, I think you covered. So our approach has been, as you've seen, that since we are diversifying at this rate, we want to ensure that more people are on the system. What we decided to divide this problem into two pieces, which means the integration piece or the automation of the data getting into Benchling piece is something that we have kind of delayed, but we have modeled the target state in Benchling. And we are able to basically have the data semi-manually cured, but submitted to the Benchling API, which we are then able to upload it within those target entities. So we have semi-automated the process, if that helps.
Can you comment a little bit on management of your LIMS system? So it sounds like the individual teams are in charge of creating their own entities and workflows. And can you comment a little bit about how that's managed?
Yeah, so it depends on the level of proficiency that the teams have with the system. For example, when Patrick mentioned Maxime, he's a very advanced user of Benchling, and we feel comfortable to designate him as a power user to give him extra privileges where he can start making edits to the workflows. And the entity modeling is a very scary area. I wouldn't encourage everyone to give blanket rights to all of your users, however smart. So that's something that so from a governance perspective, we try to keep that control. Patrick is the key person who's essentially allowed to make that level of changes. But as far as workflow designs are concerned and adding people, that level of freedom we have assigned it to certain users. Whereas there are certain communities who haven't been designated as power users. That's how we are managing.
Yeah, I'd just like to add a plug. I would love to be able to give certain permissions to certain users, like, oh, you can make data tables, but you can't make a new entity. Maybe someday soon. Right now, we've got to give away the keys to the kingdom for that. But I mean, there's a lot of trust in our company. We're still small. We're about, like 130 people right now. So we feel comfortable trusting someone like Maxime, someone like Jose, to make the right decisions there. But bigger decisions like that require a conversation right now.
When it comes to data aggregation, some of those Tableau tables that you guys showed, how did you use or leverage Benchling to help you like organize and develop that type of system to have it so where it's searchable and things like that?
Sorry, could you repeat the last part?
Sorry. How did you leverage Benchling in order to make that system searchable and able to actually interface with some of those programs?
So there's a short-term and long-term aspect of this. So Benchling comes with this data warehouse out of the box, which is a fabulous system that you can start with, because it basically denormalizes the data that you have across zillions of super normalized entities, and it gives you in a fashion that can be consumed quickly by Tableau. But then that not all of your data sits in the Benchling, unfortunately. So from a future state, at least the game plan in my mind is that we are going to build a data lake on top of their warehouse API that they have provided. I'm going to have an Elasticsearch engine running as the master level search capabilities that allows that will allow all of the users to search for assets irrespective of whether they sit within Benchling or outside somewhere. So that's the longer term. Obviously, we haven't had time to really get there because our scientists just don't stop making more materials. But that's how we're going to solve that problem. Does that help? Yeah. Cool. Thank you so much.